Okay, so in this video we're going to discuss finding the X and Y intercept on a graph. Okay, so let's just take, for example, let me draw a line here on my graph, just a random line. Okay, so let's say this is my line that I'm looking at. It's important for us to define what the X-intercept and what the Y-intercept are. Pretty clever way to name them. The X-intercept is where the line crosses the X-intercept. The Y-intercept, where the line crosses the Y-axis. So if we're looking at this picture, here's my line, here's where it crosses the X-axis. So we would say in this case, the X-intercept is the point 1, 0. And the place where the line is crossing the y-axis, or the y-intercept, would be right here. Here's the y-axis. So it's crossing at 0, -2. Okay? So, looking at the graph, pretty easy to identify what the X-intercept is, what the Y-intercept is. Now, let's take a look at a situation where, let's say we don't know what the graph looks like. We're given an equation. Well, one of the things I want to point out to you before we take a look at this example would be this. Any point that lies on this x-axis is going to have a y-coordinate of 0. So I'm just going to randomly select a few points. So I pick this point, let's say that's my x-intercept, that's going to be the point 2, 0. If I select this point right here, that's going to be the point 5, 0. If I pick this point over here, -4, 0. So notice what all the points on the x-axis have in common. All of those points, the y-coordinate is 0. So if I want to find the x-intercept, and I have an equation, I'm going to put in 0 for y. In other words, I'm going to let y equal 0 in the equation. If I want to find the y-intercept, notice anywhere, any point that I pick on the y-axis, the x-coordinate is going to be 0. Again, I could list these points. 0, -5, 0, -2, 0, 2, 0, 5. So if I want to find the y-intercept, I'm going to let x equal 0 in my equation. Alright, let's take a look at an example now. Erase this. If I have the equation, let's say 2x plus y equals 3. And I want to find the x-intercept and the y-intercept. Let's first of all start, as we're doing this, probably the best thing to do is to go ahead and get one of the variables by itself. So in this case, y equals -2x plus 3. I know that if I'm going to let x equal 0, that's going to give me my y-intercept. So to find y-intercept, I'm going to take, and I'm going to put in 0 for x. So y equals -2 times 0 plus 3. So my y-intercept would be 3. So 0, 3. And if I go to my graph, 0, 3, 0, 3 would be right here, and that's my y-intercept. Now if I want to find my x-intercept, I'm going to put in I'm going to put in 0 for y. So again, if I go back up here, 2x plus 0 equals 3. I put in 0 for y. To solve that, I'm going to divide both sides by 2. So x is going to be 3 over 2, which is 1.5. So if I go over here to my graph, 1.5, and plot that point, again, my point is 1.5, 0. Again, this is another way that I could actually create my graph of my line if I know that the line is a linear line, like this one here in the example that I just gave. Again, utilizing that method will allow you to identify x and y intercepts that maybe do not cross the graph right on a grid line and gives you maybe a fractional value. So again, just remember in summary, if I'm going to find the y-intercept, I put in 0 for x. If I'm going to find the x-intercept, I'm going to put in 0 for y. One of the other little tricks that sometimes I've taught before finding the x and y-intercept is what we call the cover method. If I know that I want to find the x-intercept, I cover up the y, and I solve that. So again, that would give me 3 over 2. If I want to find the y-intercept, I cover up the x, and again, y would be equal to 3. So again, just another little trick that you can use if you're finding the x and y-intercept, especially if it's a linear equation.